We will discuss partial derivatives. So what is partial derivatives? We define partial derivative of f with respect to x at the point x naught y naught as the ordinary derivatives of f of x y naught with respect to x at point x is equal to x naught. To distinguish partial derivative from ordinary derivative, we use the symbol delta or curl rather than the symbol D as used previously. So we start from these lines. Okay. Here is the formal definition of partial derivatives. Definition is partial derivative with respect to x. The partial derivative of f of xy with respect to x at the point x naught y naught is partial curly f over curly x or partial f over partial x at point x naught y naught is equal to limit of h approaches to 0 f of x naught plus h comma y naught minus f of x naught y naught over h provided the limit exists. So it means there are 2 points in the range. So one point is a fixed point which is called x naught, y naught. So and the corresponding point in the range is f of x naught, y naught. In the domain, the fixed point is x naught, y naught, and in the range, the fixed point is f of x naught, y naught. And the second point, which is general points, not a fixed point, the x naught plus h and y naught. So it is clear that we are just adding a small increment in x naught but not in y naught. It means we are actually calculating limit along the point x naught. So that is why we make an increment along x. So that is why this h approaches to 0 mean if h reduces to 0, then x naught will be closer to x naught. So that is the concept that a partial derivative can be defined at a point x naught y naught is partial f over partial x at point x naught y naught is equal to limit h approaches to 0 f of x naught plus h y naught is a fix, there is no change in y naught minus f of x naught y naught over h, provided the limit exists. An equivalent expression for partial derivative is d by dx f of x y naught at x is equal to x naught. So we can also write as d by dx f of x y at x is equal to x naught. So here we have mentioned that x is equal to x naught. But if you write sometime partial f or partial x, it's not necessary to mention that x is equal to x naught. The slope of the curve f of x y naught at the point p x naught y naught f of x naught y naught in the plane y is equal to y naught is the value of the partial derivative of f with respect to x at x naught y naught. The tangent line to the curve at P is the line in the plane y is equal to y naught that passes through point P with this slope. The partial derivative partial f over partial x at point x naught y naught gives the rate of change of f with respect to x when y is held fixed at the value y naught. This is the rate of change of f in the direction of I at x naught y naught. The notation for a partial derivative depends on what we want to emphasize. Notation for a partial derivative depends on what we want to emphasize. Partial f over partial x naught y naught, or fx x naught y naught. Partial derivative of f with respect to x at x naught y naught, or f sub x at x naught y naught. So convenient for stressing the point f x naught y naught. And we can also use sometime partial z over partial x. It means at point x naught y, the partial derivative of z with respect to x at x naught y naught. Common in science and engineering when you are dealing with variables and don't mention the function explicitly. Similarly, we use this partial f over partial x, or f of x, partial z over partial x, zx, partial derivative of f with respect to x. So convenient when you regard the partial. So these are actually the notations. So what is important in this page is this is the definition. So you must have to know the definition of partial derivative. So these are just explanation and notation. So the second derivative, partial derivative with respect to y. So if you make a comparison with partial derivatives of function with respect to x, here the change is in the x coordinate. And partial derivative with respect to y, you will see the change in y coordinate. So here partial f over partial y, x naught y naught, equal d by dy f of x naught y at y is equal to y naught is equal to limit h approaches to 0, f of x naught y naught plus h minus f of x naught y naught over h. So just observe the difference between partial derivative with respect to x and partial derivative with respect to y. So if here partial derivative with respect to y mean the change in y coordinate. Okay, so there is no other difference. These are just the notations. So how we write this partial f over partial y mean partial derivative with respect to y. Hmm. So you can skip these calculation, and we will start directly this example. This one, example 1. Okay. So finding partial derivatives at a point. Find the values of partial f over partial x and partial f over partial y at the point 4 minus 5 if. Okay. So what is the function? Function is f of xy is equal to x square plus 3xy plus y minus 1. And let's calculate the partial derivative with respect to x. So it will give, we can write like partial of partial x is equal to partial over partial x square plus 3x plus y minus 1 is equal to, now the derivative of this x with respect to x will be 2x, and here we will keep y as a constant. Okay, and we will take derivative of x. So derivative of x is 1, and y is again constant like 1, 2, 3, so on, because we are calculating partial derivatives with respect to x, so y will be considered as constant. Similarly, 1 will be considered as constant, so plus 0 minus 0. So what we will have, 2x plus 3y. So this is the partial derivative of function f of x with respect to x. Now we will calculate the value. So at this point, so x is equal to 4 and y is equal to minus 5. So substitute the values, we will get minus 7. Similarly, to find partial derivative with respect to y, so we will differentiate this function with respect to y. So here now x will be treated as a constant. So since x is a constant, we will get the value of this one as a 0. Okay, so this 0, and next term is 3xy. In 3xy, y is a derivative, y is a variable, but 3x is a constant. So what's the derivative of y with respect to y is 1. So that is why it will be returned as 3x. And then the derivative of y is 1. So that is why we will get 1. 1 next minus 1 is 0. So minus 0. And we will get the result as 3x plus 1. And now substitute the points. So what is the point? Point is 4 minus 5. So x will take 4 and y will take minus 5. So 3 into 4 is 12 plus 1 13. 13 is the value of partial derivative at this point 4 minus 5. The next example is finding a partial derivative as a function. So partial f over partial y, if f of xy is equal to y sine of xy. So this is the function. So it means if we take partial derivative with respect to y, then x will be as a constant. So partial over partial y sine xy. So this is the product. So that is why we will use the product formula. So y as it is, and partial derivative of sine xy plus sine xy as it is, and partial derivative of y. So partial derivative of y will be 1 and we will get this sine xy here, this one. Okay, and but for this one, so y as it is, and partial derivative of sine xy will be cos xy, and then we will take partial derivative of xy. Okay, and in this product, so uh, okay, we can revise it. So because this is the product, so y partial over partial y sine of xy, here x is a constant, so derivative of sine y is a cos y, so that is why we can write here y cos y and into derivative of xy. And the second term, because partial derivative of y over y is 1, so we will get sine xy. Okay, so y cos x y, and here partial over partial y. So x is a constant and we will get x as it is. Okay, so because derivative of y will be 1, so we will get xy cos of xy plus sine xy. Okay. So this portion you can skip this one, and we will go to the next example. Partial derivative may be different function. For example, find partial derivative with respect to x and partial with respect to y if function is 2y over y plus cos x. We treat f as a quotient with y held constant, we get. Okay, so This is the function, and we can write partial over partial x because we are computing partial derivative of function with respect to x. So here we can use the quotient formula u over v. So u over v. So v square mean y plus cos x whole square, and then v as it is y plus cos x and partial derivatives of u. U is equal to 2y. Okay. So we are actually applying formula of partial over derivatives of u over v. So u is equal to 2y and v is equal to y plus cos x. So y plus cos x whole square, then y plus cos x as it is, and derivative of u, this one. Then u as it is, and derivative of v. Okay, you are seeing is v square, v as it is, derivative of u. Okay, so then u as it is, derivative of v. So then y plus cos x whole square, this y plus cos x of partial over partial x, because now y is a constant, so this derivative will be 0. Then minus 2 y partial over partial x. So again y is a constant, it will be 0, and derivative of cos x will be minus sin x. We will simplify and we'll get 2y sin x or y plus cos x whole square. With x held constant, we get so y plus cos x whole square. Okay. Now we are calculating the derivatives with respect to y of the same function, this one. So just observe. Again we apply the quotient formula u over v square. So u over v. So v square and then v as it is, derivative of u. Now partial y over partial y will be equal to 1. So we will get this 2. So y plus cos x into 2, because derivative of y is 1. So 2 into 1, 2. Then this u as it is and derivative of v. So derivative of v, cos x is a constant, so it will be 0, and partial y over partial y equal to 1. So 2y into 1. Okay. So y plus cos x whole square and derivative 2 cos x y. Okay. So when we multiply 2 with y, it will be 2y minus 2y cancel 0, and 2 cos x, we will get the function. So next example is a similar example. Implicit partial differentiation. Find partial z over partial x if the equation. So this is the given function. So define z is a function of the two independent variable x and y and the partial derivative. So we have to calculate partial derivative with respect to x. So partial over partial x yz, okay, minus partial over partial x natural log of z is equal to partial over partial x of x plus partial over partial x of y. Okay, so partial x over partial x 1 plus this 0, and this y as it is, because y will be considered as a constant, so partial z over partial x minus partial derivative of z will be 1 over z and partial z over partial x. So by simplifying we will get partial z over partial x is equal to z over yz minus 1. And then the next example is find the slope of surface in the y direction. The plane x is equal to 1 intersects the parabola, okay, intersect the paraboloid. Paraboloid is actually a figure and is a, you can see graph. This is paraboloid. Okay. Uh, Find the slope of the tangent to the parabola at point this one. So slope is the actually the value of the partial derivative at 1, 2. So it means we need to calculate partial derivatives with respect to y. Okay. So partial over partial z, x square plus y square. So x square will be treated as constant and derivative of y square will be 2y, and when we will substitute this 2 in this y, we will get 4. And so as a check, we can treat the parabola as the graph of the single variable function z is equal to x square plus y square. So at plane x is equal to 1 uh, and ask for the slope y is equal to 2. The slope calculated now as an ordinary derivative is 1 plus y square also is equal to 2y. So our answer is the same. It means we have done in a good way. So next, a function of three variables. Given function is f of x, y, z is equal to x sine y plus 3z. If x, y, z are independent variable, then calculate partial f over partial z. So what will be the value of partial over partial z? X sine y plus 3z. So here x and y will be treated as a constants. Okay. But derivative of, we will calculate the derivative of function with respect to z. So x is a constant. So partial over partial z sine y plus 3z. So derivative of sine is cos y plus 3z and into derivative of y plus 3z. So then derivative of z will be 1, so we will have only 3 and derivative of y will be 0. So answer will be 3x cos y plus 3z. Okay. So similarly, if we want to calculate the derivatives of the given function like this one, we will have this. So you can skip this example, no need of to do this example. Okay, this one, this you can skip. Okay. So next example, partial exists but f discontinuous. Sometime it happens that partial derivative exists, but even then given function is not continuous. So this is an example of such kind of function. So f of x is equal to 0 if the product of xy not 0, equal to 1 if the product equal to 0. So find the limit of f as xy approaches 0, 0 along the line y is equal to x. Prove that f is not continuous at the origin. Show that both partial derivatives exist at the origin. So solution, since f of xy is constantly 0 along the line y is equal to x, except at the origin we have limit xy approaches to 0, 0, f of xy is equal to limit xy approaches 0, 0 equal to 0. Since f of 0, 0 equal to 1, this one, because if xy equal to 0, value of the function is equal to 1. The limit in part A proves that f is not continuous at 0, 0. To find partial f partial x, we hold y fixed at y equal to 0, then f of x y is equal to 1 for all x. And the graph of f is the line L1 in figure. Slope of this line at any x is partial f over partial x equal to 0. In particular, partial f over partial x equal to 0 at 0, 0. Similarly, partial f over partial y is the slope of line. So partial f over partial y equal to 0. Next, second order partial derivative. So when we differentiate a function twice, we produce its second order derivatives. These derivatives are usually defined by partial square f over partial x square, d squared f dx squared. Okay. Or we can say fxx. So then partial square f over partial x partial y, d squared f dx dy, or fyx, this one. These are just notation. So if we take a partial derivative of f with respect to x, and we take again second time partial derivative of f with respect to x, we will get this notation. And if we calculate partial derivative of f with respect to y first time and then again second time, so the notation will be like this one. And similarly here, if we take a derivative of f with respect to x and then with respect to y, so and derivative of f with respect to x and then y, we will get uh, this kind of notation. The defining equations are partial square f. We can also write like this one. So that these are the notation. Okay, we will go to the real example. Finding second order partial derivative of this function. So first you calculate partial f over partial x. So we'll get this one result and then apply partial f over partial y on this function. It will give another result like this partial f over partial x, and then we have applied partial over partial y. So if we apply partial of partial y, x will be considered as a constant. So e power x is considered as a constant and derivative of y is 1. Yes, and similarly derivative of cos is minus sine y. So that is why we get this result here. This one, you see this one. So this is the actually second order derivative, first time with respect to x and second time with respect to y. Similarly, there is the calculation of second order derivatives, first time with respect to y and second time with respect to x. So the mixed derivative, sometime we calculate mixed derivative partial f over partial x and then partial over partial y. So this is not so important, but just uh, remember that if we take a derivative with respect to x and then with respect to y, and first with respect to y and then with respect to x, the result will be same. So there will no change in the result. Okay, then choosing the order of differentiation. So if we are given that calculate the derivative with respect to x and then with respect to y, so it depends on the given function. The symbol tells us to differentiate first with respect to y and then with respect to x. Okay. So if we postpone the differentiation with respect to y and differentiate first with respect to s, however, we get the answer more quickly in two steps. Partial, okay, w over partial x is equal to y, and partial square w partial y partial x is equal to 1. Partial derivative of still higher term. So in the same way, this notation will be modified and the order will be increased. Calculating partial derivative of fourth order. You see, so it means first is calculated with respect to z, then y, then x, then y. Or you can reverse the order y, x, y, z. So f of y mean partial f over partial y. So and then partial f over we have applied on the first one partial f over partial x. So in partial f over partial x, we have taken the derivative of x here, but yz considered as a constant. So then again, it on this function we calculated partial f over partial y. So derivative of y is 1 and 2x is considered as a constant. And over this we applied derivative partial f over partial z. So since derivative of z is 1, so we will get this result. So it's not so difficult. So here is the differentiability. So you can just, so what is the increment theorem? Suppose that first partial derivative f of x we are defined throughout an open region R containing the point x naught y naught, and that f of x and f of y are continuous at x naught y naught. Then the change f of x naught plus del x y naught plus del y minus this uh, f of x naught y naught in the value f that results from moving from x naught y naught to another point in R satisfy an equation of the form. Okay, so differentiable function, a function at point is differentiable if partial f over partial x and partial f over partial y exist and delta z satisfy an equation of the form. So we say that the function is differentiable if partial derivative exists and the given function must satisfy equation of the form. So this is a smaller result if the partial derivative of a function are continuous throughout an open region, then f is differentiable at every point of R. So here we can also conclude that a differentiable function must be continuous. Or we can say that a continuous function must be differentiable, but converse may or may not be true. So differentiability implies continuity. If a function is differentiable, then f is continuous. So these are the some results you could be asked as MCQ, that whether is a differentiable function is continuous or not. So your answer should be true or in yes. So these are the questions. Uh, for example, the question is that find partial f over partial x and partial y f over partial y. So what will be the answer of this question? If we calculate partial f over partial x, the answer will be 4x. And if we calculate partial f over partial y, the answer will be minus 3. So it's not so difficult. This will be discussed in the online lecture.